So I'm here at Teachbeach, which is our outdoor classroom. Today I want to talk about valence safety with SWIM, sequential wave and printing machine. This is a photograph of a car equipped with the sequential wave and printing machine, SWIM. And here's another photograph of the car, Ford Focus Electric, equipped with the sequential wave and printing machine. And we can see and photograph metavalence in the extendiverse, what we call XV. Now here's a motor equipped with the SWIM, and you can see it a little bit more clearly here. This is just a green SWIM attached to the motor body as it's turning around. The shaft of the motor is fixed in a vise on a workbench, and the entire body of the motor turns around. It's kind of a way of seeing the rotating magnetic fields inside the motor. This is 3 SWIMs, a red SWIM and a green SWIM and a blue SWIM, displaying the 3 phases of the individual motor. And this is just one SWIM, a green SWIM attached to the motor body as it turns around, showing its phases. And SWIM is a tool that can be used to show various phenomenology. Here I am at this very same beach, just riding my electric bike across that dirt path up there. You can see here, this is when it's a little bit darker out. You can see off to the city over there in the photograph, a city across the lake. And what we see here is the phase voltage after going through a transimpedance current sensor. So there's current sensors attached to the phase of the bicycle. So the 3 phases of the bicycle here are brought out and connected to a set of current sensors, which then are connected to the SWIM. So the motor in the bicycle is displayed on the SWIM as we ride the bicycle along. There's some framing on here to attach things to. Here we have the SWIM showing their backup camera on an electric vehicle. And here's another SWIM. These are SWIMs that are attached to drones that are flying around, swarm of drones. So the concept of metavalence and metavision SWIM is something that I invented back in 1974. This is a picture from July 6, 1974, showing it's a photograph of an electromagnetic radio wave with a sequential wave and printing machine used to show the electric wave. And here is the SWIM used to show a photograph of valence itself. This is called metavision, the vision of vision. A meta conversation is a conversation about conversations. A meta joke is a joke about jokes. A meta argument is an argument about arguments. Metadata is data about data, like the JPEG header file of an image, for example. And this is metavision, which is the vision of vision, sensing sensors and their ability to sense. Here's a sequence of 36 pictures, a roll of 36 exposures of film, photographic film. We have here a sequence of images, 36 of them, each photograph showing this SWIM waved in front of the surveillance camera. And here the SWIM is showing the valence flux. It's showing the camera's capacity to see. Here's another example. In this example, I have a police radar. And when I discovered this phenomenon, I had an oscilloscope that my father got me that was broken. The time base didn't work on it. Someone was throwing this away because it was broken, and I was impatient and wanted to see it. Eventually I fixed it, but before I even fixed it, I just tried moving it back and forth on rollers on a desk to be able to see something on the screen. And what I discovered I thought was quite remarkable. I had it connected to a police radar, and the body of the oscilloscope formed an antenna of sorts, and as I moved it back and forth, the beam deflected in proportion to the movement caused by the oscilloscope itself, so its own Doppler shift became part of the measurement feedback system. This is kind of an extended reality. In 1991, Charles Wyckoff and I wrote a paper about this phenomenon and other related things, which we called extended reality, XR, and it extends our ability to see. We can see electromagnetic radio waves and see other things that are otherwise invisible with XR. Here's a more modern picture showing IoT, Internet of Things, smart faucets and their capacity to sense. The photograph shows the linear array cameras in the faucets, which are depth cameras of sorts. Here we see the capacity of the sensors to see. So what I want to talk about here, you can read the paper for more details on SWIM, but what I want to talk about here is extended verse, XV. The XV is a reality-virtuality taxonomy. There's 2 axes in the extendiverse. We label them reality, which is the universe made of atoms. We label that alpha. The word atom is a Greek word, and the first letter of that word is alpha. So we label the reality axis alpha, the axis going from left to right. And the axis going from bottom to top is the bits axis, the virtuality axis. Virtual world is made of bits, so we use the Greek letter beta, the second letter of the Greek alphabet, to represent the bits. So the axes are alpha and beta, the first two letters of the Greek alphabet. Here we have a useful taxonomy because it sort of divides the plane up into quadrants. In the lower left quadrant, we have diminished reality and diminished virtuality. And here we have a float tank, a sensory isolation tank, sensory deprivation tank. In a float tank, we have zero input from the real world and zero input from the virtual world. This diminished reality creates a kind of hallucinogenic state, kind of a lucid dreamlike state. This represents zero or small values. And then the real world, we've got physical reality. This is the real physical world, the real universe in which we live. A good example of a fully immersive physical reality experience is cold water swimming, where you just jump into the lake, which we'll be doing shortly. And in cold water swimming, you swim in the lake and you're connected to reality. You're fully immersed in the natural world. You know, the natural world of pebbles and water. And this is the liminal space where the three states of matter all come together. You know, you've got the earth, water, and air, where the three states of matter come together. Fully immersive reality. And then on this axis, we're in the float tank with a VR headset. And so this is a VR float tank. And the whole idea of being in a sensory deprivation tank with virtual reality puts you up on this axis, on the bits axis. No input from the real world and strictly virtual. Interestingly, we have augmented reality, which is where you have a mixture of atoms and bits, say, some alpha and some beta. And up here in this position, we've got the ice water swimming, but with a headset, with a overlay, with a augmented reality overlay. This, for example, is the Vuzix Smart Swim, and this is a augmented reality overlay headset that shows you compass, GPS, heading. We program in where the rocks are, other rock hazards and things like that. Like if there's rocks here, we've got various signals can be displayed on here that give you a heightened sense of awareness of of the actual world that you're in. Now, if we look at the XV continuum, what we really have, so here we've got physical reality, PR, augmented reality, AR, virtual reality, VR, and diminished reality, DR. PR, AR, VR, and DR are these sort of four quadrants, although it's a continuous space, really. But what we really want is XR, which is this overarching theme, which kind of encompasses all of those, and then some. XR allows us to go beyond the 100% point. That's at least its goal. So, whereas here we have reality, physical reality on the alpha axis and virtual reality on the beta axis, 100% alpha, 100% beta. And if we put on a VR headset, you could argue that maybe it's 70.7% of each, like kind of an equal length vector, square root of 2. But what we really are trying to do is to reach further out, to come way out on this axis. So we've got actually more than what the real world will give you, because we've got this heightened sense of awareness of the real world. When you're swimming with this thing, you're aware of all these ice fragments and pieces of things, and you're aware of your own body. You get your heart rate down to 30 beats per minute, perhaps. You get your heart rate down really low through biofeedback and so on. So it really amplifies your sense of awareness of both the real and the virtual. And in this sense, extended reality, XR, tries to bring you out from the origin, and it can also bring you in, because you can also use it to attenuate. So XR is this bigger space that encompasses these four and then much more. For example, with this awareness, we might, if you want to, XR can give you a point that's 150% of reality, say, and maybe 50% of virtuality. You maybe only want a little bit of virtual input, but you want to heighten your sense of awareness of the real world with safety information, overlays, GPS map, compass, heart, and so on. So you come from the origin way out past what the four realities would normally give you. And that's kind of the goal of XR, or one of the goals of XR, is to be able to navigate these other spaces. So XR is any combination of a virtual environment with reality where the virtual environment is responsive to a real or complex valued output from reality by way of real-time computation. This is the paper that I wrote with Charles Wyckoff in 1991. There's a link to it here. XV definition. XV is a single, unbounded, universal, persistent, immersive, shared XR universe. So in some sense, the Extendiverse is extended reality combined with extended intelligence. XI, the CXI, the Council for Extended Intelligence. I'm one of the founding members of it. And so a goal that we're trying to achieve with XI and with XR is this XV. Now, within this taxonomy, let's introduce a third axis, the social axis. Whereas when we're near the origins, we have atoms, bits. Here we have genes, maybe the smallest unit of humanness. So genes is a Greek word also that starts with the third letter of the Greek alphabet, gamma. So let's label these axes alpha, beta, and gamma. Atoms, bits, and genes sort of near the origin, but of course they extend out to reality, virtuality, and sociality. Now we just take our space here, and when we come out of the page, imagine we come out of the page. So we can have a communal immersive reality experience, like a communal experience in nature. We have ice water swimming together as a group. That's a communal reality experience, an immersive physical reality experience. We can have augmented reality ice water swimming together as a group. So that's a shared augmented reality experience. And of course, we can have a completely virtual experience, like shared sensory deprivation float tanks, where we get together and we experience the float tanks together as a group, or any other kind of shared reality. So that gives us the third act. So here's a conceptualization of that concept. We've got the three axes, alpha, beta, gamma, atoms, bits, genes, and more importantly, we've got this space, we've got this environment where we have environment, we have little data, big data, and we have surveillance and surveillance. And so here's a simplified version of that same diagram. XV, the Extendiverse, is the space of environment, virtuality, and valence. The taxonomy that is generated by this kind of looks at a set of octants. We can divide the physical space up if we use, say, a logarithmic scale. We can have negative values, or we can simply say what's less than a certain amount or more than a certain amount. And so if we flip those around, these axes around, we've got body, ownership, and control. BOC space, body, alpha, control, beta, and ownership, gamma. And this gives us a taxonomy of that space. Here's a little model that I made out of cardboard to kind of show this concept here. And what we have is the body represented here. This is the body, and we've got ownership represented by an owner card. This is ownership, body, ownership, and control. We've got the body, and we've got ownership, and we've got control. So, for example, this control knob symbolizes control, and so we have control, or we don't have control, more control or less control on this axis, closer to the body on this axis, like wearables, and further from the body on this axis, and then ownership on this axis. Do you own it and don't own it? So we can put various technologies here. So for example, just because you wear something doesn't necessarily mean you control it. You could even own it. So for example, if you had handcuffs, if you're a police officer with a set of handcuffs and a burglar broke into your house and you pointed your gun at the burglar and said, put on these handcuffs, maybe the burglar grabs your gun and puts your handcuffs on you. So if you're wearing handcuffs that you own, your own handcuffs, but you're not in control, then you're here. You're away from the control, but you're out here on the ownership because you actually own the handcuffs and they're on your body, so they're on the body point. Various other points like NFT would be over here. NFT is not of the body, but it's something that you own it. Don't necessarily have total control over it. So you can put different technologies on this space. A slave might exist over here, for example. A slave is of the body, but you don't control and you don't own. So, you don't own yourself and you don't control yourself. Maybe you're wearing handcuffs or chains and you don't own yourself, but you're still your body. So that slavery would be over here on this axis. So we can take technologies and taxonomize them into these 3 dimensions. So first consider the physical scale, body axis, environment versus environment, clothing analogy. Very funny, Scotty, now beam up my clothes. That's an analogy. Or car or boat analogy. A driver or boater will say, you hit me, rather than your boat hit my boat. Environment and environment. And actually, cyborgs existed more than 1 million years ago with the invention of vessels. And this is a good example of a vessel. It's very clear there's an interior and an exterior of the vessel, and we can think of environment versus environment. Environmentalism is human-centered, and the green here shows the environment, that's which is around us, and the flesh color here shows the environment, that which is us ourselves. Now consider the informatics scale, the beta axis. We've got little data versus big data. So big data is centralized versus little data, which is distributed. And now we can also consider the idea of danger, little danger versus big danger. If we say, the little danger is like the danger that an individual could possibly inflict versus big danger. Big danger maybe is the danger that a large organization might inflict. So we could think of sort of retail danger versus wholesale danger. You've got this larger scale. We often protect against little danger. We protect against things that are on a small scale, small dangers like from what individuals might cause. But we often don't protect against big dangers. So think of an analogy. You might have a mountaintop here, and there's a road going around the mountain, and cars drive by, and we have a guardrail on the little side where you could take a small fall. But we leave the big side, which is right off the edge of the cliff. We leave that no guardrail. So why is it that we lock the small door and leave the big door unlocked? We must design systems in which we protect against both kinds of dangers, little danger and big danger. That is to say, we shouldn't centralize things so much because there's a risk there, a high risk of something really bad happening when things are centralized versus distributed. And this is why, things like fiat currency have a very high risk associated with them because they're centralized. Whereas if we have something distributed like blockchain, maybe it can be designed, at least in principle, so that there's less danger from human oversight and undersight. Next, consider, finally, the social scale axis, social scale ownership axis. So this axis, gamma, the socio-political scale, or on the other side, individual ownership, is the axis, that the third axis. And if we look in the negative here, we've got alpha, beta, and gamma here, and this is the third axis, and we're sort of looking on that axis for a minute. And central ownership versus distributed ownership, big watching versus little watching, surveillance versus surveillance, big danger versus little danger. We need the right balance between surveillance and surveillance. Surveillance is watching from above, and surveillance is watching from below. And so surveillance is big watching, like the cameras mounted on lampposts or smart cities, surveillance. And then you've got little watching, which is cameras on people. And big watching, big valence, and little watching, little valence. And there needs to be the right balance between surveillance and surveillance in a well-balanced society. Ownership, because the third axis, the gamma axis, the axis of ownership, this axis here is the social political axis, and ownership is a concept that's social political in nature. So whereas alpha and beta axes are individual, gamma is a social axis, and ownership is a social construct. Photography is very much driven by ownership. I mean, you own pictures when you take them. It's interesting if you record music, you the musician retains the rights. But when you take a picture, very little rights rest with the subject of the photograph, and almost all the rights rest with the person who pushed the button to take the picture. So the ownership of the data by the photographer suggests that photography is very much along this gamma axis. It's a social construct in some sense in terms of its ownership, at least copyright and so on. So surveillance, when the images are captured by a large entity or organization in the environment around us, versus surveillance, where the cameras are usually attached to the human body, wearable. Usually, most of the time, these come down the body diagonal as this three-dimensional space, and usually when things are close to the body, they're also owned, operated, and controlled by the individual, usually, although there's outlying examples like handcuffs, for example, which are close to the body, but their ownership or control may be remote. But by and large, normally we own and operate this camera that we wear, and we can think of this as our own space. We can talk about big ownership versus little ownership. In conclusion, and going further, we welcome our external collaborators, and it would be great to have more people joining this effort. Feel free to reach out and join us as we invent the Extendiverse.